The roll of a die, the flip of a coin, randomness greets us in countless forms. We use it in games, in statistics, in our understanding of the weather. But what randomness really? For centuries, the assumption was simple. What we perceived as random was merely our lack of knowledge. A flipped coin, if we knew its exact trajectory and the forces upon it, wouldn't be random at all. Its outcome would be certain. But what if this isn't the whole story? What if, at the very heart of reality, there's a fundamental randomness, an uncertainty that's not about our limited view, but about the nature of the universe itself? This is where the strange world of quantum physics comes in, forcing us to confront the possibility that randomness isn't just a matter of what we know, but of what be known. Let's call the first kind of randomness, the one we're used to, epistemic randomness. It's the randomness of the unknown, the shuffled deck of cards, the lottery numbers yet to be drawn. We might not know the outcome, but in principle, it's predetermined. Then there's the more radical kind ontological randomness. This is the randomness inherent in the fabric of reality. Imagine a quantum coin toss, where even with perfect knowledge of every force and particle, the outcome remains fundamentally uncertain until the very moment it occurs. This isn't just philosophical musing. Experiments with particles like electrons and photons suggest that at the quantum level, this kind of fundamental randomness might be the rule, not the exception. The seeds of these ideas were sown long before the quantum revolution. Ancient philosophers grappled with the nature of chance and necessity, with Democritus envisioning a universe governed by deterministic laws, and Epicurus introducing the swerve of atoms as a source of inherent randomness. Later, thinkers like Pierre-Simon Laplace imagined a vast intelligence capable of knowing the position and momentum of every particle in the universe, implying that randomness was merely a product of our limited perspective. But the 20th century brought about a seismic shift. The pioneers of quantum mechanics, figures like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, revealed a world where certainty dissolved into probabilities, where the act of observation seemed to influence the very reality being observed. The implications of quantum randomness are profound. It challenges our intuitive understanding of cause and effect, suggesting that the universe might not unfold in a predictable clockwork fashion. Einstein, famously resistant to this idea, declared, "God does not play dice." Yet the experimental evidence for quantum randomness continues to mount, leaving physicists to grapple with its meaning. Does it mean that the future is truly open, not predetermined? Does it reshape our understanding of free will? These are questions without easy answers, but by exploring the difference between epistemic and ontological randomness, we begin to glimpse the profound strangeness at the heart of the quantum world and perhaps of our own existence.